What is neuroscience? Neuroscience is the brain learning about itself. Neuroscience is the hardware on top of which the software of you is built. Neuroscience is the core building blocks because of which you and I are sitting here and we are having this conversation. Everything is neuroscience and neuroscience is everything. And you may not believe me now, but at the end of this talk, you may see what I mean. This is a class, but it's a class about you. So unlike any other class you've ever attended, I'm going to be talking about you and why are you the way you are. How much do you know about your brain? Well, start off with, this is what the brain is shaped like. When you talk of the brain is divided into something called as lobes. The idea of lobes is that the brain is divided into these arbitrary sections. Each section has a particular job to play, has a particular role to play. The main 4 lobes of the brain are the frontal lobe, which is at the front of the brain. And this is where all your calculation, your logic, your reasoning, all of this is happening at the frontal lobe. Right behind the frontal lobe is an area called as the parietal lobe. This is where your 3-dimensional structures are maintained. This is the map finding area of the brain. So when you tell me that you are in a room and there's a fan above you, there's a floor below you, your parietal lobe is what knows all of this. At the back of the brain is the occipital lobe. This is the part of the brain that helps you to see things. And at the bottom is the temporal lobe. The temporal lobe is what helps you remember things, that helps you feel emotions, and also helps you to hear. This is the rough outline of the brain. And all these different areas come together to give you the experience of being you. Now, this brain didn't just come up directly. Throughout time, through the last 2 billion years, our brain has been constantly evolving to become the way it is right now. And the way it has evolved is from down to up. So the earliest organisms had a brain which was just this much. And then the organisms developed till here, and then here, and then here, and then today we are at this level. So at every stage of evolution, more and more of the brain kept getting added on top. But when we talk of evolution, the important reason why we have to talk about evolution is that all the things that you feel right now, when you feel angry, when you feel sad, when you feel hurt, all of those emotions didn't come up just today or 10,000 years ago or even 1 million years ago. The fundamentals of those emotions were actually laid many, many millions of years back when we talk of the primitive brain or the reptilian brain. So when we talk of the reptilian brain, we talk of the brains that even reptiles had. So frogs, snakes, even those creatures had the reptilian brain. And the reptilian brain had something called as the limbic system. Your limbic system is primarily designed to help you survive. Now, put yourself in the shoes or in the feet of a frog. It is out in the jungle and the frog needs to survive. What does it need to do? It needs to hunt for food. So whenever you find food, the frog will go towards it, and it needs to run away from predators. So if it sees a snake, it will run away from it. And it needs to mate. So it needs to find a partner, it needs to mate so that its species can propagate. So the limbic system is primarily concerned with feeding, running away from danger, and mating or reproduction. The story since then, every stage of evolution that has happened since then has only been fine-tuning these basic limbic system drives. So whatever has evolved has never gone away. It has only become more and more sophisticated. So today, when we talk of ourselves as evolved creatures with prefrontal cortex, that doesn't mean that we don't want to eat. That doesn't mean that we don't run away from danger. That doesn't mean that we don't want to reproduce. The only thing is that because of all these years of evolution, we now have sophisticated means of doing those things. Evolution in a nutshell, all right? This is actually a 1-hour workshop of just evolution, but I have given it to you in 2 minutes. So far, so good. Now, let's talk of the survival game. So suppose if you are Mother Nature, okay, imagine or if you are God, and you have to design a system where creatures survive. Basically, you've done all this hard work, you have spent all this energy creating these animals, but they just keep dying all over the place. Nobody survives. What's the point? So you need to come up with a system that will ensure that those creatures at least want to survive. So what you do is you create a carrot and stick formula. You say that if you do some things, I will make you feel very, very good. And if you do some things, I will make you feel very, very bad. So if you do some things, I will give you a lot of pleasure. And if you do some things, I will give you a lot of pain. And that is a way of training the organisms to go towards some things and to go away from some things. So again, if you are a rabbit in the jungle, you want to go towards a bright fruit hanging in the garden because it's high calories. You want to go and eat it, but you'd want to go away from the dark. You don't want to go into a dark cave because who knows what dangers might be there. Even today, when you go to a market, you will notice that your eyes are immediately drawn to bright colored objects, bright red, bright green, bright yellow, which is why a lot of advertisements, food companies use these colors of red and yellow to highlight their food. There's a reason why McDonald's is red and yellow, KFC is red and yellow, Swiggy uses red. So all of these marketing, especially related to food brands, use red and yellow because it is primarily trained in our brain to look for those things. Whereas the reason that all children are afraid of the dark is because of that primitive impulse of let's stay away from the dark. We don't know what is there. So this balance, the seesaw of pleasure and fear or pleasure and pain has been what has been driving evolution towards the state that we are in. And it is still not different. We are still not done with evolving. We are still very much part of that chain of evolution. So think of it like a seesaw. And I'll put some random object in front of you. How do you know whether you like it or not? It is the seesaw that decides. If there is more fear than pleasure, you will go away. If there is more pleasure than fear, you will go towards. If it is ambivalent, then you are neutral. Right? This is the thing that all marketing strategists are trying to figure out. This is what Tinder is trying to figure out. This is what Swiggy is trying to figure out. What makes you swipe right? What makes you swipe left? What makes you click the buy button? What makes you click add to cart? Everything is decided by fear and pleasure. This is the survival game. Now, it is time for us to take it one step further. When I say fear or when I say pleasure, what do I mean? Pleasure is modulated by a hormone called as dopamine. How many of you have heard about dopamine? It's a chemical, it's a neurochemical, it is actually a neurotransmitter, and there is a whole network in the brain dedicated to dopamine. So when dopamine hits a particular spot in your brain, you feel very, very, very good. In fact, when dopamine hits that spot again and again, you get what is called as addiction. You like it so much that you want to keep on doing it so that dopamine keeps hitting that spot. For those of you, for the nerds here who really want to know, that spot is called as nucleus accumbens, and it is in the depth of the limbic system, nucleus accumbens. And this is where dopamine will go on hitting every time you do something that evolution is very happy with. Like, good boy, keep eating that fruit. Yes, good boy, keep mating. Yes, keep reproducing, which is why food feels good, which is why sex feels good. So all of these things we are trained to like, our brain is trained to like. What about things that are not good for you? What if you want to keep jumping into a cage which is full of tigers? What if that is something you want to do? Well, that is not good for you. The tigers will eat you up. So you need to have something called fear, something to hold you back. You need to have a brake in your car. So the braking system in the brain is an area called as amygdala. The amygdala is also part of the limbic system. It is actually very close to nucleus accumbens. So those two are almost friends. Those two are childhood friends that have grown up together over millions of years, and they're not very far apart, but those two come together to play this seesaw of pleasure and pain, towards and away, to and fro, yin and yang. This cycle of amygdala and nucleus accumbens keep us on track. That is why you know that you cannot go too much behind something. That is why you know you cannot go too much away from something. If any one of these overwhelms you or takes over your mind, then your train gets derailed. Because too much dopamine, you're addicted. Too much fear, and you are in anxiety, panic. You can't do anything. So in both the extremes, you are paralyzed. In both the extremes, you are useless. You cannot really function properly. But if these two things are in balance, then you are on track. All right. Fight or flight is essentially part of the fear response. So when the amygdala is activated, initially it is just to pay attention. But as soon as your attention is on that thing and amygdala continues to get activated, you activate the fight and flight response. So for example, if there is a cobra in your room right now, you will not be listening to me. You have bigger problems. So your attention is completely focused on the cobra, and your muscles will all suddenly tense up because you have to run. Your heart will start beating loudly because all those muscles need blood, because in 2 seconds you're going to be running for your life. So quickly pump blood so that all your muscles get blood. Your eyes will become dilated so that you can take in more information. Your breathing becomes faster. Your skin becomes cold because all that blood is now going into your muscles, and your brain is completely focused on that one thing. So this is what are the symptoms of anxiety attacks or panic attacks. So that is all because of uncontrolled amygdala activation. Interesting observation. The one situation where you get both, or one of the funny situations where you get both amygdala and dopamine activation, is when you fall in love. So when you fall in love, especially when you fall in love the first time, there is a lot of dopamine, but there is also a lot of amygdala activation, which is why you feel very good, but your heart is racing, your skin is cold, you're breathing fast, you can only pay attention to that one thing, you can't think of anything else. So yeah, love really screws up your mind. I'm just saying. The only way to control the fight and flight response is to reduce amygdala activation, which is to reduce the level of threat. So if you feel like something is threatening you, then you will be threatened. Then the amygdala will get activated. But as soon as the feeling of threat goes away, amygdala will stop getting activated. So for example, a snake charmer will not get that same level of amygdala activation as somebody who's seeing a snake for the second time in their lives, right? If they're seeing a snake for the first time in their life, also they may not get an activation because they don't even know this is dangerous. Let's talk of dopamine and amygdala a little more. When I say dopamine, how does it control behavior? So when we talk of pleasure and pain and keeping the train on track, how does dopamine control behavior? Dopamine controls reward networks. So in the brain, whenever you do an action that the brain approves of, it activates reward networks. So the brain is literally bribing you. Evolution is bribing you to go on doing something. So dopamine activates reward networks. And when those reward networks get activated, those chemical changes that happen in your brain leads to physical changes. And it is this combination of chemical and physical changes that we call as happiness or satisfaction or pleasure. The next time you say that I am happy, what you mean is that dopamine is getting activated in your reward networks, and that is triggering a chain reaction of chemical to physical events, which coming together gives you the sense that you call happiness or satisfaction or pleasure. And all of these we associate with well-being. When we say well-being, we mean that our reward networks are saturated and we are feeling good. All right. But this is only half the story, because the other half of the story is your amygdala activation. So when amygdala gets activated, it activates pain networks or fear networks. And when the fear network is get activated, it leads to a series of negative emotions, negative chemical reactions that we associate with either worry or anxiety or panic or distress, rage, anger. All these negative emotions are associated with amygdala activation. I am simplifying this a little bit, but so understand that each one of these different words do have different connotations and slightly different networks, but amygdala is a common factor for all of this because all of them makes you go away from something, right? And Yash has just raised an interesting point that one cannot exist without the other. I believe that the whole Harry Potter novel series is just a way of talking about dopamine and amygdala. But then, so is every fiction book ever. Every story that says love conquers hate basically talks about how love and hate, dopamine and amygdala, kind of need each other. So, love conquering hate is a very simplistic term, but love cannot exist without hate, and hate cannot exist without love. You need to have both. You need to go away and you need to go towards. Only going towards is addiction. So, you cannot have one without the other.